morning, student. Today we can continue our topic of physics, that is the gravitation. Okay. So last point which we have learned about the projection of satellite, and in that projection of satellite we reached to that critical velocity. What do you mean by critical velocity? That is the maximum or minimum horizontal velocity which has been given to the satellite so as to put it into a circular orbit around the earth is called as the your critical velocity. Means up to this minimum velocity will be required to set that satellite into, that is, earth's particular stable orbit. Okay, so that is the critical velocity. So for calculating the critical velocity, we have considered the two forces, that is the gravitational force which is in between the earth and the satellite. Okay, and that gravitational force which we have calculated is Gmm by r square. And what is r here? R is the what will be the radius of that circular orbit, okay, above the surface of earth, whatever the height we have set the satellite. So that will be the Gmm by r square, and that will be balances by the your which force, so that is the centripetal force, and that is the mv square by r. So m is the mass of the satellite, v is the critical velocity of the satellite, and r is the, that is your what is that, radius of that particular circular orbit. And after calculating that things which we got it, the critical velocity is equal to a square root of gm by small r, or gm by r plus h. Okay, so what is the expression which we have calculated? Critical velocity is equal to under root of gm by r, or what is that r? R plus s, gm by r plus h. So that is the your critical expression for the critical velocity that you have learned. Okay. And if you want to find out that critical velocity near the surface of earth, okay, if suppose the satellite has been set near the surface of earth, okay, this is above the surface of earth, near the surface of earth, what will be the condition? R plus h is approximately r, and so therefore critical velocity, the expression will becomes gm by r. And when these things will happen, when h is very smaller as compared to r, therefore we have neglected that r, so h, so therefore it will be, expression will becomes critical velocity is equal to square root of gm by r. Now I want to find out the expression. This is the first expression, this is the second expression which we can consider. This is at particular height h, and this is the near the surface of earth. But now today we want to find out the critical velocity in terms of acceleration due to gravity. If I want to find out the critical velocity in terms of the acceleration due to gravity, then how we can find out that things? Okay, so particularly when we are calculating the acceleration due to gravity, so here as we know, so force is equal to gmm by as r square. So therefore force means mg, but m into g is equal to g m by r plus h square above the surface of earth. So will get cancelled. So at particular height, gh is equal to gh is equal to gm by r plus h square. And so therefore, what will be the expression for gm, bachche log? Gm is equal to gh into r plus h square. Now, I will substitute this value of equation 3 in equation 1. Okay, so that you will get from equation 1 and 3. Okay, means what I will do, I will substitute value of 3 in equation number 1. So the critical velocity, that expression will becomes under root of gm, I will put the value of gh into r plus h bracket square upon r plus h. Okay, so here in that case, what I will do, r plus h and r plus h will get cancelled. So the critical velocity will becomes r plus h into g suffix h. Okay, So at particular height, your critical velocity will be in terms of acceleration due to gravity. Okay. But now again near the surface of earth, if I want to calculate near the surface of earth, sir, what will be that expression? So now again the question comes, r plus h is approximately r, and so critical velocity is equal to, so that is r into g. Okay, r into g or g into r, so that will be the critical velocity. Okay. But look, so this critical velocity is near the surface of earth. Now next expression we want to find out, sir, that critical velocity, okay, critical velocity of the satellite close to the surface of earth, uh, of the earth of a radius r and mean density rho, means we want to calculate near the surface of earth gm by r. This is the critical velocity, and we want to calculate this velocity in terms of density of the earth. Okay, so then we can calculate for the next critical velocity in terms of its mean density. Okay, so I can calculate. So near the surface of earth, critical velocity near the surface of earth, critical velocity near critical velocity near the surface of earth in terms of कशाच्या फॉर्म मध्ये पाहिजे मुलांनो, in terms of mean density, in terms of mean density. Okay, mean density, so that is supposed to be rho. Okay, so now we have calculated the critical velocity above the surface of earth is gm by r plus h bracket square. Okay, so that was the your expression. Okay, what is that critical velocity? Gm by r. So what was that expression? Gm by r plus eh. Okay, not a square. So now if you want to find out this near the surface of earth, this is above the surface of earth, and this is above surface of earth, at a height of, that is this h. Now near the surface of earth, near the surface of earth, the critical means your radius will becomes r plus h will be approximately r. So therefore critical velocity is equal to under root of gm by r plus h will be, r plus h will becomes r. So this is the equation number 1. Now I want to calculate in terms of the density, mean density, this expression. So what will be that expression? But we know the density is equal to mass upon volume. So therefore mass is equal to density into volume. So mass is equal to, what is volume? 4 by 3 pi r cube. Okay, what is the expression for that? Your mass will be rho into 4 by 3 pi r cube. If I will substitute this value, so the expression will becomes Vc, critical velocity, is equal to g into rho into 4 by 3 pi r cube upon r. Okay, so now I have substituted the value of that your your mass in terms of density. So now what I'll do, I'll cut this r square will be left now, because one r will get cancelled, and so therefore this expression will becomes critical velocity is equal to 4r square, that 2r will be out. In that under the square root, what will be the things are remaining now? That is your pi, okay, then now 4 is out, pi 1 by 3, okay, 1 by 3 pi rho and g, okay, pi rho g by 3, okay, or Vc is equal to 2r under root of rho pi g by 3. So that will be the critical velocity in terms of mean density. Okay. So this expression of critical velocity in terms of density, where rho is the mean density, okay, of the earth. G is the gravitational constant, R is the radius of the earth, and Vc is the critical velocity. Okay, so that is the expression for that critical velocity in terms of the mean density. Okay, once you got that critical velocity in terms of acceleration due to gravity in terms of mean density, then question arises, what will be the time period of satellite to revolve around the planet? Okay, so that we want to calculate now. So I'll rub these things and we can come to the point, time period of satellite. Okay, so how we can calculate the time period of this satellite? Okay, so this is the expression for particularly which we have calculated for the critical velocity. Now we can come to the point, that is the, what is the time period of satellite? Period of satellite. Okay, what is the period of satellite? That is the capital T. So that we want to define first. Then now we want to find out expression. Okay, how that expression for the time period of satellite. Okay, and on what factor this satellite depends. Okay, so that point we want to prove. Moreover, we want to prove T square is directly proportional to R cube also. So these are the different things are there. So what do you mean by period of satellite? Period of satellite means time taken by the satellite to complete one revolution around the earth. Okay, so that is called as the period of satellite. Okay, so this is the orbit, so this is the earth, and now if I will say this is the radius of the earth, this is the particular height, this is the mass of the satellite which is going to move with some velocity, that is the critical velocity which we can consider. Okay, and now so this is the mass, and the satellite is going to revolve around the earth in a stable orbit. So suppose this is the center of the satellite. Okay, and this will be considered to be a earth symbol. Okay, this is this earth, this is the center of the earth, this is the radius, okay, of the satellite above the surface of earth. So that we have been shown here. So now we want to find out, sir, what is the time period of satellite? So now when this satellite is revolving around the earth's surface, so how much time is taken by that satellite to complete one revolution? So what is time period? The time taken by the satellite, time taken by the satellite to complete one revolution around the earth or planet. Okay, around the earth is called time period of satellite. Time period of satellite. Okay, again I will define what is that. Your time period or period of satellite, time taken by the satellite. Okay, time taken by the satellite to complete one revolution around the earth. Okay, is known as the time period of the satellite. It is denoted by T. So now how we can find out that time period of satellite? Here what is the m? M is the mass of the earth. Here m is the mass of earth. What is small m? Mass of satellite. Mass of satellite. Okay. And h is the height above the surface of earth. Height. Okay. Above the surface of earth. Okay. Above the surface of earth. Okay. and what will be its critical velocity with which the satellite is going to move around the earth. So that gm by small r means r plus h, okay, above the earth's surface. So now if I want to find out the time period, so the time period t is equal to distance covered by the satellite in complete one revolution. Okay, distance covered in one revolution divided by its velocity. Okay, distance covered in one revolution divided by velocity of this satellite. With what velocity satellite is moving? Distance covered will be 2 pi r, okay, where r is r plus h, and velocity will be critical velocity. So therefore time period of this satellite will be 2 pi r, and what is the critical velocity? Gm by r, gm by r, where r is r plus h. So therefore, so the time period of the satellite will be 2 pi r into under root of r upon gm, Now what I will do? I will put this r inside. So time period is equal to 2 pi under root of, here r will becomes r square into r upon gm. So time period of that satellite will be 2 pi into r square into r will be r cube upon g into em. So that will be the expression for time period of satellite. Okay. And if suppose I am putting the value of, if I am putting the value of, so that will be r cube, r means r plus h, okay, so that also you can put it here. So therefore this expression will becomes, what is r here? R plus h. This is the radius of orbit of that satellite. So therefore time period will becomes 2 pi under root of r plus h cube upon gm. So that will be the expression, correct expression for time period of satellite. Okay, r plus h bracket raised to cube upon gm. So on what factor it depends? Dependent factor. Dependent factors. कोणकोणत्या फॅक्टर्स वरती डिपेंड्स करतं मुलांना क्रिटिक टाइम पिरियड? फर्स्ट इट डिपेंड्स अपॉन the your radius of the earth, it depends upon height above the earth satellite. Then now it will also depends upon, on what factor it will depends, radius of circular orbit, radius of circular orbit, म्हणजे मुलांनो ती सर्क्युलर ऑर्बिटची रेडियस किती आहे त्याच्यावर सुद्धा तो डिपेंड्स करतो. ओके. मास ऑफ द प्लॅनेट अबाउट विच द सॅटेलाइट इज रिव्हॉल्विंग, म्हणजे एम, मास ऑफ द प्लॅनेट. हा जो एम आहे मुलांनो हा प्लॅनेटचा मास आहे, मास ऑफ प्लॅनेट. ओके, मास ऑफ प्लॅनेट याच्यावर तो डिपेंड्स करतो मुलांनो. मास ऑफ द प्लॅनेट, ओके, radius of the planet, the radius of circular orbit, height of a satellite above the earth's surface. Okay, मुलांनो मग आता तुम्हाला काय रिलेशन दिसतं की जेवढी तुमची हाईट वाढेल तेवढा टाइम पिरियड सुद्धा काय होईल रे? हाईट समजा तुमची वाढली तर टाइम पिरियड सुद्धा वाढेल, आणि हाईट जर कमी केली तर टाइम पिरियड सुद्धा मुलांनो काय होईल? तुमचा कमी होईल. म्हणजे टी decrease, time period decreases as h decreases and vice versa. Okay, again t is also but t is independent on mass of the satellite. Okay, it means it does not, time period does not depends upon, time period does not depends upon mass of the satellite, mass of satellite च्या मासवर त्याचा काहीही इफेक्ट नाही, लक्षात घ्या. मुलांनो याच इक्वेशन वरून आता आपल्याला हा जो तुम्ही आता एक्सप्रेशन दाखवलाय टी इज इक्वल टू 2 पाय आर, हा त्याच्यावरून आपण किंवा याला टी इज इक्वल टू 2 पाय आर क्यूब अपॉन जी एम. ओके, मग मुलांनो हा आर प्लस म्हणजे तुमचा एच होता, म्हणजे टी इज इक्वल टू 2 पाय आर प्लस एच अपॉन जी एम. मी आता याला एक काम करतो, याचं जर स्क्वेअरिंग ऑन बोथ साइड करून टाकलं, समजा त्याला इक्वेशन नंबर 1 म्हणून टाकू. From equation 1 we can also say like this, for the time period of the satellite we can say from equation 1 squaring on both sides, t square is equal to 4 pi square r cube upon gm. मुलांनो t square is equal to 4 pi square gm into r cube. मग आता हा जो 4 pi square gm कॉन्स्टंट आहे, म्हणजे t square is directly proportional to r cube. मग आता t square काय होता रे, square of time period of satellite is directly proportional to cube of its radius of the orbit. Okay, t square is directly proportional to r cube. आणि मुलांनो तुम्ही जर अगदी नियर द सरफेस ऑफ अर्थ जर घेतलं, हेच इक्वेशन near the earth surface r plus h, okay, is equal to r. So therefore this expression can also be written as t is equal to 2 pi under root of r upon r cube upon g plus m. Okay, हे केव्हा रे, near the surface of earth, near the surface of earth. Okay, हे त्याचं एक्सप्रेशन होतं मुलांनो, r cube upon that your what will be the expression g upon m. आता मुलांनो नेक्स्ट एक्सप्रेशन आपल्याला काढायचं आहे. ओके, expression for period of satellite when revolving at height h, and hence obtain the expression for period of a satellite in terms of acceleration due to gravity. मग मुलांनो आपण आता टाइम पिरियडचं इक्वेशन इन टर्म्स ऑफ आपल्याला ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी काढायचं आहे. मग आपण लिहून टाकूया आता. ओके, सो व्हॉट विल बी द एक्सप्रेशन फॉर सॅटेलाइट, ओके, above the surface of earth, and second in terms of acceleration due to gravity. Okay, चला आता इथे लिहू आपण time period of satellite in terms of acceleration due to gravity. Okay, मग मुलांनो आपण आता above the surface of earth, above the surface of earth, काय लिहिलं रे टाइम पिरियडचं इक्वेशन, t is equal to, what is the expression for t, that is equal to 2 pi under root of r plus h bracket raised to 2 upon g into m. Okay, gm. Okay, so that will be the gm. So that was the your expression. मग आता मुलांनो या एक्सप्रेशन मध्ये मला gm ची व्हॅल्यू काढायची इन टर्म्स ऑफ ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी, बट वी नो m into g is equal to gmm upon r plus h bracket square. Mm get cancel above the surface of earth. So what is the value of gm? That is gh into r plus h bracket square. If I put this value here gm, so what will be the expression for time period? Time period t is equal to 2 pi under root of r plus h bracket raised to 3 upon gm ची व्हॅल्यू टाका gh into r plus h bracket square. So therefore this expression can be written as t is equal to 2 pi under root of r plus h square will get cancelled with this. So therefore r plus h upon g into h. म्हणजे मुलांनो आपण त्याला कशाच्या फॉर्म मध्ये लिहिलं, त्याला acceleration due to gravity. So therefore th is equal to 2 pi under root of rh upon gh. आणि मुलांनो याला जर आपल्याला नियर द सरफेस ऑफ अर्थ लिहायचं राहिलं असतं तर नियर द surface of earth, near the surface of earth, t is equal to 2 pi r upon g. Okay, because r plus h is approximately r. Okay, म्हणजे मुलांनो हे एक्सप्रेशन आपल्याला असं लिहिता आलं म्हणजे r by g. Okay, so this is way how we can write down that expression in terms of the your acceleration due to gravity. Okay, मग मुलांनो आपण आता हे टाइम पिरियडची इक्वेशन आपण तर लिहिलेत. ओके, आता पुढचं इक्वेशन आपल्याला काढायचं आहे सॅटेलाइट ऑर्बिटिंग व्हेरी क्लोज टू द अर्थ सरफेस अँड इन टर्म्स ऑफ इट्स मेन डेन्सिटी. ओके, सो शो दॅट टाइम पिरियड ऑफ रिव्हॉल्युशन ऑफ सॅटेलाइट म्हणजे तुम्हाला त्याचा मीन डेन्सिटीच्या फॉर्म मध्ये ते एक्सप्रेशन आपल्याला काय करायचं मुलांनो फाइंड आउट करायचं आहे. ओके, नियर द सरफेस ऑफ अर्थ अँड इन टर्म्स ऑफ मीन डेन्सिटी. मी आता एक काम करतो मुलांनो मला इन टर्म्स ऑफ आपल्याला या फॉर्म मध्ये काढायचं आहे. calculate the acceleration due to gravity. Acceleration नहीं period of satellite in terms of mean density near the surface of earth, near the surface of earth. मुलांना आता mean density मध्ये फॉर्म काढायचा असेल तर मी काय करेन above the surface of earth 2 pi r plus h cube upon gm हा तुमचा टाइम पिरियड आहे. मग near the earth surface okay r plus h is approximately r, so therefore t is equal to 2 pi r cube upon g into m. आपण हे वरती लिहून ठेवलं. आता मला मीन डेन्सिटीच्या फॉर्म मध्ये पाहिजे. मग आता m ची व्हॅल्यू परत मी डेन्सिटी इनटू व्हॉल्यूमच्या फॉर्म मध्ये मुलांनो टाकून देतो. म्हणजे मला आता इथे लिहावं लागेल but mass is equal to density is equal to mass upon volume, that is the mass density into volume. Therefore mass of the earth is equal to density into 4 by 3 pi r cube. And if I substitute this value here, then that expression will becomes t is equal to 2 pi under root of r cube upon, so g into now rho into 4 by 3 pi r cube. Okay, 4 by 3 pi r cube. तर मग मुलांनो आता हे एक्सप्रेशन आपलं आता कसं तयार होतंय बघा. r cube इथून उडाला. ओके, r cube get cancelled. So time period is equal to in terms of your 3 upon 0 4 pi मग आता हा 2 पण बाहेर काढून घेऊ. t is equal to 2 pi by 2 3 upon 0 pi 2 but cancel. आपण पाय पण मध्ये घेऊन जाऊ वाटल्यास त्याला. ओके, मग त्याच्यात पाय जर मध्ये गेला तर तो पाय स्क्वेअर होऊन जाईल मुलांना. हा पाय मध्ये गेला तर मग 3 into pi square upon g into rho into pi. Pi will get cancelled. So therefore t is equal to under root of 3 pi g into rho. T is equal to 3 pi under root of g into rho. This is the expression for time period in terms of density. मग काय रिलेशन येते रे? टाइम पिरियड इज इनवर्सली प्रोपोर्शनल टू mean density. Okay, inversely proportional to means it when 3 pi by g will be remains constant. Okay, आणि मुलांनो सॅटेलाइट revolving very close to the earth surface, t is independent of radius when rho is the constant. म्हणजे तो रेडियस वरती डिपेंड्स करताना दिसत नाही. So this is the expression for your time period of satellite in terms of mean density. Once you got that expression, then we can come to the point, sir, what are the Kepler's law of planetary motion? The Kepler, he has given the 3 laws for planetary motion. So that laws also you can see, and then we can go for the some numericals also. Okay. So now what are the 3 Kepler's law of planetary motion? You are must be familiar with the 3 laws of Kepler's for the planetary motion. Okay. So will tell me which are the 3 laws? Kepler's law of Kepler's law of planetary motion. Planetary motion. Okay, Kepler's law of planetary motion. Okay, Planetary. T-A-R-Y. And Kepler's. Okay. So now that means once you have learned the time period of satellite, then what are the 3 laws of Kepler's? Okay, of the planetary motion. The first law of Kepler, that law is also labeled as law of elliptical orbit. Law of elliptical orbit. Okay, law of elliptical orbit. What was that first law? That means your Kepler. So according to the Kepler's first law, which is that all the planets are revolving around the sun in a elliptical orbit, and in which the sun is one of the focus of that elliptical orbit. So therefore, what is that law? Every planet revolves. Every planet revolves around the sun in which orbit? In around the sun in an elliptical orbit. In an elliptical orbit. Okay. All the planet means every planet which is revolving around the sun in elliptical orbit with the sun at one focus of the ellipse. With sun at one focus of ellipse. Ellipse as the focus. So one of the focus of that ellipse will be that your sun. Okay, means now if this is the elliptical orbit, all the planets are revolving. So now here this is semi-major axis, this is semi-minor axis. So sun is one of the focus, okay, of that ellipse. So that is the sun. Okay. And now this is the first distance, this is the second distance near to the sun, that planets which are revolving. And so this is the velocity of planet. Okay. So they are moving like this in elliptical orbit. Okay. So this is the semi-major axis R. Okay. So that is called as semi-major axis. Okay. मग मुलांनो आता हा झाला पहिला लॉ की तो काय म्हणतो कोणताही प्लॅनेट every planet which is revolves around the sun in an elliptical orbit with the sun is at one focus of the ellipse. हा त्याचा काय असेल मुलांनो फोकस असेल. ओके एक लक्षात घ्या. हा पहिला लॉ होता. नाउ सेकंड लॉ ओके त्यालाच आम्ही कोणता लॉ म्हणतो माहिती आहे मुलांनो? लॉ ऑफ इक्वल एरिया इन इक्वल टाइम. लॉ ऑफ equal area in equal time. ओके मग सर हा सेकंड लॉ काय सांगतो बघा मुलांनो. तर तो म्हणतो लाईन जॉइनिंग द कोणाची लाईन जॉइनिंग द radius vector of sun to planet shifts out equal area in equal intervals of time. ओके म्हणजे मुलांनो हे तुमचं स्विफ्ट आउट हा रेडियस वेक्टर तुम्ही जॉईन केला हा असा स्विफ्ट आउट करतोय. तर हा याचा आणि याचा एका विशिष्ट टायमिंग मध्ये तो एरिया काय करतो, सेम एरिया कव्हर करतो मुलांना. ओके, व्हॉट इज दॅट लॉ इज टेलिंग. अगेन आय विल डिफाईन दॅट लॉ. तर मुलांना तो लॉ असं सांगतो, हा फोकस होता ना, एक मिनिट बोला. हा फोकस जर असेल इकडे तर तुमचा हा एरिया जो आहे हा कव्हर केलेला इथून तर इतका, हा याचा आणि याचा एरिया सेम असेल. ओके, म्हणजे हा P1 टू P गेला आणि हा इकडे P1 P2 P3 P4, P1 P2 P3 P4. ओके, मग मुलांनो तुम्ही काय सांगितलं आता, व्हॉट इज दॅट युअर सेकंड लॉ. द रेडियस वेक्टर ड्रॉन, द रेडियस vector drawn from sun to planet sweeps out equal area in equal intervals of time, equal time interval. That is aerial velocity of a planet will remains constant. That is the aerial velocity of a planet around the sun. Aerial velocity of a planet around the sun remains constant. Okay, so what do you mean by this statement? This statement is telling, okay, this statement is telling that whatever the area swept from, suppose this is P1 to P2 will be same as area of P3 P4. Both the areas will be remains the same. Okay, area of P1 P2 is equal to area of P3 P4. ओके, हे दोघं एरिया कसे असतील मुलांना, त्यांनी स्वीप आउट केलेले सेम असतील. F is the focus or position of the sun. Okay, the law also obeys the conservation of angular momentum. हा काय ओबे करतो रे, conservation of angular momentum. कसं रे मुलांनो, कॉन्झर्वेशन ऑफ अँग्युलर मोमेंटम. हा कसा उभा करतो, कोण सांगतो बरं. आता तो काय म्हणतो बघा, जर ज्यावेळेस हा प्लॅनेट ज्याचं मास m असेल, तो ज्यावेळेस P1 पासून P2 पर्यंत जातो मुलांनो, त्यावेळेस याचा आता इथलं डिस्टन्स जे आहे, हे डिस्टन्स सन पासून खूप जास्त असतं. Okay, distance of that planet from the sun is very large. So therefore MVR ह्या पोझिशनला m mass is the same V1 R1. As the R1 is a more, so therefore V1 will be less. The velocity कमी असेल. But when this will become this planet near to the sun, तर त्यावेळेस त्याचा मोमेंटम बघा mv2r म्हणजे अँग्युलर मोमेंटम आहे. हा मास तर सेम आहे. मुलांनो आर कमी म्हणून तुमची वेलॉसिटी इथं कशी असेल, जास्त असेल. ओके, म्हणजे तो मुलांनो एरियल वेलॉसिटी हा एरिया कव्हर म्हणजे with respect to that time will be remains the same. So therefore radius vector drawn from the sun to the planet sweeps out equal area in equal intervals of time. Okay, that is aerial velocity around the area covered per unit time of a planet around the sun always remains constant. Okay, now sir, what is the third law of Kepler's? Okay, now first law, second law. Sir, now we can come to the point, what is the third law of Kepler? तर मुलांनो हा जो थर्ड लॉ होता, थर्ड लॉ ऑफ केपलर, this is regarding law of time period. Law of, we can also say that period. आणि तो तुम्हाला माहिती आहे मुलांनो, काय सांगतो माहिती आहे, T square is directly proportional to R cube. म्हणजे मुलांनो square of the time period of satellite around the planet is cube of is the cube of the square of time period of satellite around the planet is directly proportional to cube of cube of cube of semi-major axis, cube directly proportional to cube of semi-major axis, cube of semi-major axis. Okay, it is directly proportional to cube of semi-major axis of elliptical orbit, okay, of elliptical orbit. that is आपण आता हा लॉक कसा लिहिणार मुलांनो, म्हणजे तुम्ही जो सांगितलं आता हे बघा, हे जे डिस्टन्स तुमचं R1 असेल, समजा हे R1 असेल, ओके, हे तुमचं सेंटर, ओके. तर मुलांनो आता इथं मला असं लिहिता येईल R1 प्लस R2, हे डिस्टन्स R2 आहे, हे डिस्टन्स R1 आहे, ओके. हे इथलं R1, हे डिस्टन्स तुमचं R2, मग R1 प्लस R2, R1 प्लस R2. ऍक्च्युली मला ही डायग्राम बदलायला लागली, ओके. आता ही कशी काढायला लागेल मुलांनो? सो दॅट व्हॉट इज द टाइम पिरियड, समजा हा तुमचा इलेक्ट्रिकल ऑर्बिट होता, दिस इज द इलेक्ट्रिकल ऑर्बिट, ओके. मुलांनो हे बघ, हा सेमी मेजर ऍक्सिस आहे, हा सेमी मायनर ऍक्सिस आहे, हे डिस्टन्स तुमचं R होतं. मग आता हा समजा फोकस आपण सन इथे घेतला, तर आता मी सूर्यापासूनच म्हणजे सन पासूनच हा जो फोकस आहे, इथलं हे डिस्टन्स आहे, हे जर समजा मी R1 केलं आणि हे इकडचं डिस्टन्स जर R2 केलं, तर मुलांनो मला असं म्हणता येईल R1 plus R2 is equal to 2 times R. So therefore R is equal to R1 plus R2 by 2. Okay. तर मुलांनो हा R काय आहे तुमचा सेमी मेजर ऍक्सिस आहे, ओके. R1 plus R2 where R is the semi major axis, where R is semi major axis, ओके. मुलांनो हा जो तुमचा R1 जो आहे लॉंगेस्ट डिस्टन्स फ्रॉम दी सन, ओके. त्या R1 काय होतं तुमचं लॉंगेस्ट डिस्टन्स. मग हा जो लॉंगेस्ट डिस्टन्स असतो R1 वेअर R इज द सेमी मेजर ऍक्सिस, R1 इज द लॉंगेस्ट डिस्टन्स ऑफ सन from sun to the planet, and so that is called as aphelion, okay. Aphelion, okay. Aphelion, aphelion, okay. And R2 is the shortest distance, okay, shortest distance of sun to planet, shortest distance from the sun, okay. Of sun nahi, from sun, and that is called as perihelion, perihelion, okay, perihelion, okay. तर मुलांनो हा झाला तुमचा एक लॉ, that is t square is directly proportional to r cube. If we remove the sign, then now that formula can be written as t as also as t square is directly proportional to r cube. So therefore t square is equal to some constant into r cube. मग मुलांनो मी याला असं पण लिहू शकत होतो, t is directly proportional to r raised to 3 by 2. Okay, you can write down this formula like this also. Or t where a is the semi major axis, then t is directly proportional to a cube. Okay, a is equal to r is equal to semi major axis, then t is directly proportional to a raised to 3 by 2, a raised to 3 by 2, or T cube is directly proportional to a square. Or this can also be written as T is directly proportional to R1 plus R2 by 2 raised to 3. You can write down this expression like this also. Okay. So this is all about your Kepler's 3 laws of planetary motion. So today we'll stop here. Tomorrow we'll take problems on that: weightlessness, communication satellite, polar satellite, binding energy, and escape velocity. So we'll proceed one by one, okay, of that satellite. Today we'll stop.